So students, today we will study the entropy production in a chemical reaction. Okay. Since we have studied two types of the system, one is open system, second is the closed system. In the open system, number of moles of the system they vary, but in the closed system, number of moles they remains constant throughout the whole system. Okay, so for every closed system there is an extensive properties, there is every extensive property like gives free energy, enthalpy, internal energy, work function. So all these extensive properties in the closed function, they depends upon the number of moles in the open system. So in addition to the dependence upon the other parameters, they also depends upon the number of moles when they are studied in the open system. Okay, since we have studied the open system, and for the open system, if we take the extensive property, that is the internal energy. So basically internal energy जो है, that depends upon the entropy of the system, volume of the system, and number of moles present in the system. Okay, E is a function of SV and Nj. Okay, so when we differentiate this dE, so just apply the method of differentiation. First differentiate E with S into ds, then differentiate E with V into dV, and at the last we differentiate E with Nj number of moles into dNj. Okay, so when we differentiate first term, that is E with S, other two parameters they are kept constant, and in the second term we differentiate with V, S and Nj they are kept constant, and in the last term when we differentiate with Nj, S, V and all other parameter, all other number of moles except Nj, they are kept constant. Okay, so the last term is written in summation. Summation indicates, what does summation indicates? Summation curly E divided by curly Nj when j varies from 1 to j. Okay, this indicates the sum of the variations of internal energy with the number of moles of first component, then with the number of moles of second component, then with the number of moles of third component, plus so on. So overall we write it in the summation. Okay, so summation indicates the sum of the differentiations of internal energy with the separate number of moles of every component. Okay, now as we know from the first law of thermodynamics, the first law of thermodynamics formula is change in internal energy is given by dq minus dw. Okay, work done is given by the formula pdv, and entropy is given by the formula curly q with time. So from here change in heat is given by tds. So put this value of dq and dw in this expression. So de becomes tds minus pdv. Okay, now in this expression there are two variables, that is ds, change in entropy of the system, and there is change in the volume of the system. So first we differentiate this equation with respect to entropy, keeping volume and number of moles they as constant. Other two parameters they kept constant. So first term क्या बनेगी? When volume is kept constant, the change in volume becomes 0. So second term जो है pdv, that will vanishes, pdv becomes 0. We are left only with de. Differentiate करो with respect to ds. Okay, keeping volume and nj as constant. You can see from the right side we are left only with the t. tds को left side में ले आओ, we are left with only temperature. Okay, secondly differentiate this equation with respect to second parameter, that is volume, keeping S and Nj as constant. Okay, so what we left with, when S is kept constant, ds becomes, change in entropy becomes 0. So first term, that is TDS, it will be 0. So TDS becomes 0. We are left only with the minus PdV. So we are left with change in internal energy with change in pressure. This is equals to minus P. We are left on the right side only minus P. And S and Nj, they are kept constant. Okay. So you can see, when we differentiate E with S, we are getting temperature T. When we differentiate E with B, we are left with minus, E with V, we are left with minus P. So in the starting equation, this equation, first term जो है, that can be replaced with V, second term can be replaced with minus P. Okay, everything else remains same. So just rewrite this equation by putting these values. We get dE is equals to TdS minus PdV plus summation J, change in internal energy with change in number of moles in dNj, volume, entropy, and Nj minus 1, they are kept constant. Okay. Now, what is chemical potential? There are different relations for the chemical potential. Chemical potential is equals to change in Gibbs free energy with number of moles, as we already studied, at constant temperature, pressure, and number of moles. Okay, but this is also equals to negative change in work function with number of moles. But when temperature, volume, and number of moles, they are kept constant. This is also equals to change in enthalpy with number of moles when pressure, entropy, and number of moles, they are kept constant. This is also equals to change in internal energy with number of moles when volume, entropy, and n-1 and j-1 number of moles, they are kept constant. So there is 4 relations for the chemical potential. Every relation, it depends upon the parameters which we kept constant. For example, in the first expression, if we kept temperature and pressure as constant, then chemical potential is the change in free energy with number of moles. And you can see in the last expression, when we keep volume and entropy as constant, then chemical potential can be written as change in internal energy with the number of moles. Okay, so we can easily replace in this expression, this term, it can be replaced with, you can see here, it can be replaced with chemical potential mu J. Sorry, here is mu J. So rewrite that equation again by putting last term, in the last term, chemical potential. First term same, second term same, and in the last term it will become mu J into dN into J. Okay. So find out TDS from this equation. TDS is kept on one side, everything else it is taken on the right side. Okay. So now from here, find out the value of ds. ds is equals to dE plus PdV divided by T minus 1 divided by T summation J mu J into dNj. Okay. Now ds is the total entropy of the system. This is the total entropy of the system. Okay, this total entropy of the system, this is the sum of the two types of entropies, dis plus des. Okay, what is dis and des? dis. This is the change in the entropy. This is the change in entropy due to what? This is the change in the entropy of the system due to the changes which are occurring within the system. The changes which are occurring within the system that induces some change in entropy, which is known as internal change in the entropy. I represents the internal. E represents here the external change in entropy of the system. Okay, external change in the entropy of the system, it arises when the system absorbs or emits when the system it absorbs or emits some amount of heat. Okay, so after absorption or emission of the heat by the system from the surroundings, whatever change occurs in the system due to the changes from the exterior, that contributes to the external entropy of the system. Okay, so now as we know, change in internal energy, external entropy of the system, this is given by change in heat with temperature. So dq is given by T into des, and as we know from the first law of thermodynamics, dE is given by dq minus pdv, okay, and dq is equals to dE plus pdv. Okay, so basically dE from this relation, this is equals to TDS. Okay, so we get this expression. From here we will calculate the external entropy of the system. This is dE plus pdv divided by temperature. Okay, now let us suppose in the starting we will give the numbering to the equation. Put this equation as equation number 1, this is as equation number 2, and this will become equation number 3. Okay, put the equation number 3 and equation number 2 in equation number 1. Okay, in the second equation, ds is given by dis plus de. So left side, first equation, left side is replaced with this one, and in this equation, second equation, des, it is given by this formula. Okay, so you can see from the first equation, ds is dis plus des is given by equation number 3, and on the right side remains everything same. This is equals to dE plus pdv divided by t minus 1 by t summation j mu j into dnj. So second term it will cancel out. We are left only with dis. This is equals to minus 1 by t summation j mu j into dnj. So now we define the rate of reaction or extent of reaction. Let us suppose the extent or rate of reaction, it is represented by chi. Okay, then the number of moles of the system, jth component, during the chemical reaction, the number of moles of the reactants, they changes. Okay, let us suppose at any instant of study, Nj is the number of moles of the reactant. So this is basically equals to the number of moles of the system in the initial state plus mu j into chi. Chi represents the extent or rate of reaction, and what is mu j? Mu j represents the stoichiometric coefficients. stoichiometric coefficients of the system. Stoichiometric coefficients are what? For example, A mixed with B, A and B, number of moles basically. So they are the stoichiometric coefficients of the system. So from this equation we will find the value of the extent of reaction. This is equals to Nj minus Nj naught divided by mu J. Now differentiate this equation. So we will get d chi this is equals to, this is equals to d chi into if we take Vj on the left side, right side we are left with change in the number of moles of the jth component at that time of study, and minus d n j naught. N j naught is the number of the moles of the system when we start the chemical reaction. So at the starting these number of moles, they always remains constant, and constant differentiation of this constant becomes 0. So we are left only with d n j. This is equals to mu j into d chi. Okay. So now put this value of dnj in this equation at the last. So we will get dis. This is equals to minus 1 upon t summation j mu j into mu vj into d chi. D chi is taken out of the summation and we are left with only Vj into mu J. So next is the rate of entropy production. Rate of entropy production is what? It is the change in the entropy with time. Entropy is given by this expression and its rate is given by change with time. Okay. So this is on the right side. Simply differentiate chi with dt. Everything else remains same. Mu j into mu j. Okay. And as we know, chemical affinity of the reaction. This is given by the formula minus summation Vj into mu j. This is chemical affinity. So in the above equation, this summation and negative sign, this is replaced with affinity, that is A. So we are left with 1 by T d chi with dt into A. Okay. So entropy production of the system is, finally we have to find the entropy production for the chemical reaction. This is given by 1 upon volume into change in entropy with time. This is the formula of the entropy production. So this is equals to 1 upon V. Dis upon dt is given by this formula 1 upon T d chi upon dt into A. Just rearrange this. T is taken outside and V is taken inside the bracket into A. So this is the final formula for the entropy production in a chemical reaction. Okay, and this bracket 1 upon B d chi upon d tau, this gives us the rate of the reaction per unit volume. This is the rate of the reaction per unit volume. Okay, so this is the last conclusion of the entropy production in a chemical reaction.